Another thing that we do with introductory biology classes, and arguably all biology classes, is we keep coming back and reminding ourselves of what the scientific method is. And the reason why we do this is because the scientific method is a methodical way of helping us to be able to answer questions, explain the world around us, and as I like to keep coming back to, it helps us to be able to find solutions to problems. Now, the thing with the scientific method and why we keep coming back and revisiting it in our biology classes and reminding ourselves of how this process works is because we are arguably always doing the scientific method. You may not have thought to yourself, I'm going to do the scientific method today. In trying to solve this problem and trying to explain what's going on, I'm going to follow those sequential steps. We normally don't think about it in this really formalized way. So we come back and we look at the formal steps, and then we see how we're using the scientific method, not only in our personal lives, but also in the process of science in order to really answer some of those challenging questions and come up with solutions to really, really difficult problems. So that's the other thing that I love about the scientific method, is that it can be really casual in our personal lives, or it can be used in a very powerful way to help us to come to really, really important solutions to challenging problems. So in general, we always start our scientific method with an observation. Then we come up with some kind of hypothesis or a research question. And when we write a hypothesis statement, they're brutal to write, and so in the lecture slides, I give you those prompts that I see a lot in the literature. The prompt, I hypothesize that something is happening or something will happen. The format that I really like to use, and I think is more intuitive to my personal life, is that if-then. If I do the following things, then something will happen. So generally when we write a hypothesis or we're thinking about a hypothesis, we'll be thinking in those terms and those prompts in that language. It's equally okay to write a research question. Instead of using that formal statement, we can just phrase it as a question. Once we have our hypothesis, we're going to conduct an experiment. Now, it takes a lot of time to make an observation, do some background information, see if anybody else is observing the same thing, see what other research has been done in regards to what it is we're looking at. Writing the hypothesis takes a long time, really codifying what it is we want to do. If we've written a really good hypothesis, then it's almost like writing a recipe for our experiment. So the experiment is the fun part. This is why most people go into science. It's the playing around with stuff part of the scientific method. And what's always interesting is this idea that when we go into science, most of our time is going to be spent communicating our findings, analyzing our data, and the beginning parts, making the observation, writing the hypothesis, and doing the background research. We don't actually get a lot of time to do the experiment. So, for example, a friend of mine researches prairies out in Nebraska. If she gets 8 weeks of experimentation and her field in her field season, that's a really, really good field season. She spends most of her time doing a lot of the other steps of the scientific method. She doesn't get to spend as much time out there doing the experimentation. The experiment will generate our data, and the data is what we use to make our conclusions. Now, there's generally only 2 conclusions that we're going to make in science, either correlation or a causation conclusion. Once we've come to our conclusion, it is absolutely crucial that we communicate. If we have done our research and we don't talk about it, we might as well have not done our research at all. So I think communication is an incredibly important part of the scientific method. And you'll notice down here on the whiteboard, I added start the process over again. Because inevitably, once we answer one question, once we've done some research, inevitably we have a lot more questions that come up. And so what you find is that you get stuck in this iterative process. Okay, now I've answered this one, let's answer the next question. Let's deal with the next problem. And it keeps going and keeps going and keeps going until decades have passed and you look back and you go, wow, I didn't expect for my life to take that kind of turn. I just wanted to answer one question. And somehow that led to literally the rest of my life. This happens to a lot of researchers, a lot of scientists, and a lot of us as individuals as well. So I might give you a quick example, probably an example that you've experienced at least once in your life, though I wish you wouldn't have, but inevitably this is how our lives seem to go. I want to give you an example of the scientific method and how it really is a personal thing, but you probably haven't thought about it in these formalized terms. So let's say you wake up in the morning and you go outside, put the key in the ignition of the car, turn it, and nothing happens. Oh, that's the moment of panic, right? You panic, you freak out, probably some really pretty words are said at that moment. You turn it again, nothing happens. You turn it again, the lights aren't coming on, the radio's not coming on. I hate that feeling. Hopefully, the first thing that goes through your head is you look down and you collect a little bit of data. You're like, wait a minute, my gas tank is full. I just got gas a couple of days ago, so gas can't be the reason. The next most logical reason for this observation is the battery is dead. Oh, I hate that. So you made an observation. You then have a hypothesis. And it's not like you formally say, I hypothesize that my battery is dead. If I take my battery to AutoZone or one of the other auto places, then they will find that some of the cells, most of the cells in my battery are dead and not functioning anymore. I will get a new battery and see if that works. We don't think about things in these really formal terms, but in the moment of that observation unfolding into the logical next step of, please let it only be the battery, you pop out the battery, your experimentation. You take it into the mechanics. When you take it into the mechanic place, they're essentially going to run an experiment. They're going to hook your battery up to the sensors, and the sensors are going to start to collect some data. The experiment, you have your independent variable. Your independent variable is the battery. We're comparing your battery to all of the other batteries that have ever existed and all the batteries that we know are sitting on the shelf. If your battery comes back and has most of the cells dead, then the next logical step is to get a new battery. In your experimentation, you take that new battery home. When you take that new battery home, you put it in your car, hook it all up, put the key in the ignition. Vroom! The car starts. You've collected more data. It was the battery. The battery was causing your car not to start. Whew! If you bring the battery back home and you put the key in the ignition, vroom! It doesn't start. Oh no, please don't let it be all of the other things that could be wrong, because you know that just means lots and lots of money, and it's going to be a lot of time, and it's going to be a lot more hassle than just being able to replace that battery. So you made an observation. You had a hypothesis. You tested that hypothesis by going to the auto store, buying a new battery, coming home, putting it in the car. When that car went vroom, you had your conclusion. That battery caused my problem. Or I now have to start the process over again, formulate a new hypothesis, go do some experimentation. Hopefully it doesn't cost me too much. Now, of course, you could be talking about it when you get to work or get to school or get to wherever it was you're heading to. People are going to ask you, how was your day? You'd be like, battery dead. And everybody's going to go, oh, it sucks. I've been there. How much did it cost you? You're going to communicate. We all communicate about what happens to us. We develop this larger data set, this larger set of experiences by sharing what we do. So in science, when we're formal researchers, we're going through all of these steps. We're doing the same process. We just formalize it. It looks a little bit more complicated. But if we keep coming back to our personal experience, as at the times where we've made observations, tried to come up with a solution, tested that solution, hopefully that was the solution. If it wasn't, then we tried it all over again, tried a different solution, and then talked about it. We have done the scientific method. So in our first chapter, in the beginning of a biology class, we always come back to this sequential, methodical way of explaining things and being able to answer questions and solve problems. In science, we have to have a formal, shared way to be able to communicate things. Now, it's been said that learning biology is like learning another language. We're going to have a lot of terms that you're probably not familiar with. But we have to have that shared language in order to effectively and quickly communicate and talk about really complex situations, really complex issues. So I have a couple of tips for you when it comes to terminology. The first is make sure to get the terms memorized. Now, when you're making the definition for your terms, try to avoid things that sound like they work but aren't really accurate or effective at defining the term. So, for example, we're going to learn about the organelle inside of a cell called the mitochondrion. And a lot of times people define it as the powerhouse of the cell. And for most of us, it doesn't mean anything unless we're working at Byron Nuclear Power Plant and we understand how a power plant, a powerhouse, is able to make energy that then is used by other systems. This term, powerhouse of the cell or power plant of the cell, doesn't really help us to understand what the mitochondrion is doing. So instead, define that mitochondrion organelle as the organelle that makes ATP energy. That's going to help you more in Chapter 7 when we're talking about cell respiration and how cells are able to break glucose and make ATP energy using the mitochondrion organelle. So make the definitions shorter, make them more accurate, make them make sense to you. And because flashcards and definitions are often very personal, you can be casual in your language. You can use references that resonate with you. You could even use inappropriate language. Just be careful when you're trying to explain it to somebody else that you clean it up a little bit in that explanation. So define the terms in a way that makes sense to you. I try to do that throughout this course, so you may notice that my definitions are a little bit different. I'm trying to make them more personal and stick a little bit better in your brain. Use flashcards. Make sure somebody is quizzing you on those flashcards. We seem to need that accountability. Now, because this is an online class, you may want to do something like find somebody in class that you can email or even text with, and text each other vocabulary words back and forth. That might be a really good way to quiz each other. You may even want to set up something like a Zoom meeting or a Google Meet where you can quiz each other back and forth. Don't do it for long periods of time. Only do it for about 5 to 10 minutes. After that, our brains are done with trying to learn terminology. So terminology is going to help us to be able to communicate clearly. But there may be times when you see terms and you don't know how they're pronounced. So in a couple of chapters, I'm going to use the term xylem. X-Y-L-E-M. Xylem. And you may have never seen that term before and not know how to pronounce it. If you don't know how to pronounce a term, use the technology. Go to Google, and what I like to do is type into Google how to pronounce, and I put my term in, and it gives me all these options to listen to people pronouncing the term. So have Google pronounce it for you. And of course, you can always reach out to me. You can email me or stop by one of the Zoom meetings, and I can help you just learn how to say the term. Get good at saying the term, say it over and over again, get those definitions stuck in your head, and that's at least half the battle to an introductory biology class.